race to win wars and explore the stars, have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. Velcro, inspired by nature and now used in space. Radar, the war-winning technology now keeping us safe in the skies. The hang glider, the important NASA link to this graceful aerial sport. We reveal the amazing science and manufacture behind these wicked inventions. We're all familiar with Velcro hook and loop fastenings. They're everywhere, from clothing to cable ties and everything in between. Hook and loop fastenings have become a part of our daily lives. But did you know how one man's canine friend inspired its invention and how it's even found its place amongst the stars? The first and original hook and loop fastener was invented in Switzerland by Swiss electrical engineer Georges de Mistral.
It all started with a gentleman called Georges de Mistral. In the 1940s, he was walking with his dog in the Swiss Alps. Many times he found these burrs from the burdock plant in the fur of his dog. But after a while he started to study it and put it under the microscope, and he was fascinated and inspired by this piece of nature. So he invited several scientists and people who knew about manufacturing, and 10 years later, in 1958, he invented the whole thing, was granted a patent, and the Velcro brand and the Velcro company was born.
Although these hook and loop fastenings are often referred to as Velcro, Velcro is now actually the name of the company founded by Georges de Mistral, rather than the name of the product. So, how do these hook and loop fastenings actually work?
How the science works on this is that you have many hooks on a small area, and on the reverse side that it's hooking into, lots and lots of fibrous material that when you push the two parts together, the hooks basically work their way into the material, and as they're released, they find a strand onto which they can hook. Not every hook actually has to hook, but the multiplication of many hooks hooking onto an opposing side will allow the hook and loop fastener system to work very well and actually maintain quite a bit of strength.
A common misconception about Velcro hook and loop fastenings is that they were invented by NASA for use in the Apollo space missions.
NASA didn't invent the hook and loop fastener system. They used it a lot. They were the ones that helped bring it to great popularity in the public image.
It became an easy way of attaching tools to the astronauts and even of attaching themselves to the spacecraft. So, for example, they would have it on the bottom of their shoes so they could stand on the floor of the spacecraft, and even use it to attach themselves into their sleeping compartments.
That popularised the image. It started to become widespread use of product.
Although hook and loop fastenings were never invented for use in space, they've still proved an indispensable addition to the complex technology on board space shuttles and stations. Velcro hook and loop fastenings have a multitude of uses, and the products utilising this technology continue to increase in numbers. Who would have ever thought that a man walking his dog could result in such a useful and versatile invention that is still being produced in growing numbers today? Velcro hook and loop fasteners are manufactured worldwide, including at this facility in Spain.
Since 1958, we are still today the original manufacturer of Velcro hook and loop, and we are still innovating. It started really with textiles, because Georges de Mistral, he invented this Velcro hook and loop, and people were looking at it and said, hey, this is quite interesting, but what to do with this? So the application started naturally, like I said, in gloves and garments. If you are a small child, your shoes are with Velcro hook and loop, and also your sailing jacket, etc. But the company has evolved far beyond this. We now have applications in a very wide variety of industries and consumer applications, and that's why we love to come to work in this company.
The production of Velcro hook and loop fasteners begins at the warping machine.
Step one is warping. Warping consists in converting the individual ends coming from a bobbin into a bigger spool or reel, which contains as many ends as will be needed in the following process, which is weaving.
This part of the machine is called the creel. It is a framework that is fed with bobbins of yarn that form the beam. Around 800 yards of yarn are fed through in parallel that will form the length of the tape. This is the sectional warping machine. Yarns with a wider gap are fed through here to avoid them mixing together. After this process, adhesive is applied in the slashing machine. The beams made in the warping process are put together to form one in a process called slashing. To begin this process, the yarns are coated in glue. They are then separated and sent through an oven of hot air that dries the glue. The yarn is then passed through the reeds, which are parallel strips of wires in a loom. This separates and maintains every strand. A sensor can detect a break in any one of the hundreds of yarns that will immediately stop all machinery, ensuring a high level of quality control and a reliable hook and loop product. The yarns are then each put together to form the final beam. This huge beam will then go directly to the loom to begin the weaving process. In the weaving process, there are two beams in each loom, one that forms the base of the hook and loop textile and another that forms the loops. Different types of yarns are used to produce both the hook tape and the loop tape. The weaving process consists of two distinct sets of yarns, one called the warp and another called the weft. These are interlaced with each other to form a fabric. The warp is the set of yarns that are first laid out on the loom. The weft yarns are then woven under and over the warp. Once our textile has been woven, it is then moved on to the dyeing stage. The raw textile material is put into this barrel. The barrel is then inserted into the machine in which the colouring process takes place. The process takes around 2 to 3 hours in total.
With the use of water and temperature, these are pressurized machines which basically using chemicals and dye stuff fix the dye stuff onto the fibers of hook and loop, basically getting the final desired color.
Once completed, the barrel is then inserted into a drying machine where the newly coloured material is dried out. This coloured material then moves on to the hook cutting machine. This step is vital and, as the name suggests, creates the hook for the finished Velcro hook and loop tape. Little cuts are made in the material that forms the hooks. Once completed, the tape is cut to its final width.
We have more than 35,000 different products, and they're all designed for a certain application. And this can be light, so very light, or very strong. And this can be very strong. So strong that you can hardly remove it.
And that's it. The Velcro hook and loop tape is complete, ready to provide yards of strong grip to the user. Now that's a wicked invention. The modern world of regular air and sea travel, military operations, and even weather forecasting simply could not function the way it does without the use of radar, the object detection system that puts radio waves in use in order to determine the range, angle, and velocity of objects. But what was the catalyst for the invention of radar, and what role did it have to play in World War II during the success of the Battle of Britain? The term radar was first used by the United States Navy in 1940 as an acronym for Radio Detection and Ranging. However, it was nearly 50 years before this, in the late 19th century, that German physicist Heinrich Hertz showed that radio waves could be reflected from solid objects. In 1904, the German inventor Christian Holzmeier was the first to use radio waves to detect the presence of distant metallic objects when he demonstrated the feasibility of detecting a ship in very dense fog. It was this discovery that would lead to radar as we know it today. With the possibility of war becoming a reality during the 1930s, several countries began secretly developing and researching radio technology that would allow them to detect objects such as ships and aircraft. These countries knew that by creating a reliable radio detection system, they would gain a great advantage over their enemies.
very quickly people saw its huge capability from a military perspective. Certainly as the Second World War was looming, and people then realised that this was a very good asset to have. The British side was probably then the most advanced, as evidenced by the Battle of Britain, but certainly the Germans had a capability they were developing too. So it is interesting how something which is technically starts to become feasible, how people really need to put on the best people, the best technicians and scientists to get one step ahead.
Although the Allies' success in the Battle of Britain was down to a number of factors, including the highly skilled pilots and tactical superiority, radar played a huge part in the victory.
What is interesting is that I think that warfare, or the threat of a war, really acts as a focus and as a catalyst for change and high-end research and development. And many of perhaps the best and most notable inventions which we had throughout history have come through a wartime situation.
Of course, as new technologies are developed in order to gain the upper hand in warfare, counter-technologies are devised. This was no different with radar, as radar jamming systems were created in order to effectively hide from the opposition. Since World War II, radar technology continued to be improved, creating more and more complex systems in an effort to beat enemy radar jammers. As commercial flights became more popular in the 1960s and the skies began filling with planes, radar proved vital in air traffic control. The technology was developed to a point that every commercial and military aircraft now has its own code, allowing air traffic controllers to identify not only the location of the aircraft, but also which aircraft it is, whether that be a commercial airline or an allied or enemy fighter.
Supplementary radars in some ways started off again from a military use, information friend or foe, or IFF as everyone knows it, which is the coding, which gives each aircraft a radar response which you can then identify that particular aircraft. That's used in the military to identify literally a friend or a foe, but also in the commercial environment to understand exactly which big commercial airliner is which one. And so the aircraft controllers can actually control the right aircraft.
Today, the use of radar extends much further than just locating and identifying aircraft. It can even be used to predict the weather, giving accurate real-time information on incoming weather systems, such as when they will arrive and how long they will last.
I mean, one thing about radar is the way it's evolved over the years, certainly since the Second World War, into multiple different uses. I mean, at sea, every ship has several radars for collision avoidance, for navigation. Ports have them for sort of port control. The police, of course, use the radar speed guns, which I'm sure many people have come into contact with at various times. But also the weather radars and usage is quite fantastic today. I mean, everyone watches the weather forecast, certainly the BBC News and the weather forecasts use live radar information to show the tracking of various weather conditions and formations across the country. So there are multiple uses of radar which have come out from that's invention in the late 30s.
From its early development to the accelerated research as a result of World War II, radar has become a vital invention for today's world, making it one truly wicked invention. The US Air Force's stealth fighter owes its bizarre shape to the designer's efforts to minimize its radar signature by scattering the radio waves that try and detect it in flight. In this experiment, our intrepid tester is going to show you why the plane's angular sides work so well. What you will need: a dark surface to conduct the experiment on, a pair of scissors, a light meter, a torch, a paper plate, some white card for the shapes, and duct tape. To begin, turn the paper plate over and cut a hole into its edge that is big enough for the torch to slide into. Then, cut a flap in the centre of the plate, which is big enough for the light meter to stand up in. We now need to mark out our experiment area. Take a strip of duct tape and create a line on the dark surface. This is where we place the shapes that will be tested. Next, take another piece of tape and mark where our torch will sit. We are marking these areas to make sure each test is conducted under the same conditions. Take a piece of card and bend it in half to create a flat surface. This will be our control shape. Create a curve and a triangular shape out of pieces of card that is the same size as the flat shape. Switch on the light. The torch will provide light which will mimic radar's radio waves and will hit the card and then bounce back to the light meter, giving a strength reading. The higher the light reading, the more light has been reflected, meaning a low radar stealth rating. To create a nice dark controlled environment, we place a box over our first flat sample and measure the results. 53 lux or lumens, that's the benchmark. We carefully place the curve shape in the same position and monitor the light reading. 37 lux. It seems that the curve is deflecting more light away from the sensor than a flat surface, so the curve is definitely more stealthy. But what about the sharp angles of the triangular shape? 24 lux, less than half the reading of a flat surface, and even better than a curve. So, with a torch and some household items, we have proven why the stealth fighter is such a funny shape. Its edges scatter the incoming radio waves more efficiently than other shapes, meaning it fools the radar into thinking it is a much smaller object than it really is. Soaring gracefully through our skies, hang gliding is a popular pastime for those wishing to take to the air. But did you know NASA played an important role in the development of this exciting aeronautical sport? The hang glider we are familiar with today may have first taken to the skies in the 1960s, but its origins go back a great deal further.
The story of hang gliders goes right back to the 1890s when a pioneer called Otto Lilienthal, even before the Wright brothers, was experimenting with unpowered flight. His gliders were in fact hang gliders. It's just that unlike the hang gliders of today, he was suspended by his shoulders so he could only move his lower body, whereas a modern hang glider pilot can move more of his body and has better control. Unfortunately, the fact that his gliders weren't as well controlled as today's meant that Lilienthal himself was killed in a glider accident.
After the Wright brothers' success in developing powered flight in 1903, the aeroplane became the dominant shape in our skies. But hang gliding enthusiasts still experimented with foot-launched flyers with limited success, and it would be the Regalos, a husband and wife team, who would design a new wing in the late 1940s that would lead to the hang glider shape we recognise today.
They started investigating whether a triangular-based wing with two cones effectively slit in half and put side by side could be a much better wing because it has an aerodynamic shape, it has the ability to capture air a bit like a parachute, and also is flexible. The fabric in between can fluctuate with the wind and air so that you can work with it, and it'll be like a parachute, but a gliding parachute.
After developing their wing into a toy kite, in the late 1950s, the inspired design came to the attention of NASA, who tried to implement it as a recovery system for their Gemini space capsules.
The problems that beset it were that you needed a 50-foot or minimum Regalo wing, and it wasn't actually that easy for astronauts to steer. They did work out that it could be deployed at supersonic speeds and it could last quite a lot, had to be quite strong, but it still was a bit unstable. And so it could never be fully deployed for space work.
Though the Regalo wing was ditched by NASA, their tests proved the concept could fly, and in the 1960s, designers across the globe continued to perfect the power wing into the hang glider of today. Founded in 1973 in Orange County, California, WWII's Wing have made and sold over 25,000 professional hang gliders to flying enthusiasts all over the world.
The product that we make at WWII's Wing is actually a range of products. We manufacture 5 different levels of models of hang gliders. Some of them are suitable for new pilots that are just taking instruction. Some of them are suitable for more advanced intermediate pilots, and then we have competition class models that are used for cross-country flying and competition flying. And each one of those products has its own special challenges.
First, blueprints for the latest glider are drawn up on computer, which is connected to a computer-driven XY cutting machine. This cutter is able to mark out the designs and cut out panels of special UV-resistant mylar fabric needed to form the sail. Before stitching, multiple layers of the sail will have to be cut, gathered together and laid out on a table to be pinned or taped together so that they can be sewn.
The challenges of making hang gliders are that a hang glider is a relatively complex product. A hang glider is an aircraft, and all aircraft are relatively complex. And a hang glider is particularly complex because it's part science and engineering and part art and technology.
At the sewing station, the first stage is to apply tip-mounting webbing to the sail, which is the material that actually anchors the sail to the airframe of the glider. Once the sail is complete, it is taken back to the layout table for the addition of yet more panels. This process is repeated 3 times. Will's Wing make all their own components with a vertical machining centre, which grinds solid blocks of aluminium, making fabricated brackets and parts for the airframe. The carbon fibre rods for the hang glider are put through a special tube drilling machine, which can hold and drill holes through the tubes at a precise location and a precise angle. This allows Will's Wing to produce multiple repeat parts of the same specification from the main airframe. Once all the components, sails and airframe rods have been prepared, it's time for final assembly. The airframe has to be assembled and connected to all the support cables, which run both on the outside and the inside of the rods of the frame. The cables have to be carefully attached and fastened into place, making sure the tension is correct. Then, before the sails can go on, the serial numbers and guideline stickers are attached.
I would say that what makes our gliders unique is the level of attention that we pay to trying to maintain quality and consistency, both in the design and in the manufacture. From a design standpoint, one of the most important things is to make sure that a glider has the right handling qualities. If a glider is hard to fly, it doesn't really matter how much pure performance it has. It won't be a suitable product for the customer. And one of the things that we do is we factory test fly every glider that we make before we send it out. And most of this test flying is done by 2 of the executive officers of the company. So there's a lot of experience behind it, and it helps to maintain the quality of the product.
Once the airframe has been assembled and the cables attached, it is time to insert it into the sails. The 2 outer rods will each go into a wing sail, while the centre rod will act like a spine. The support cables, handlebars and the body harness will then attach to this main frame. The handlebars are raised to make sure the cables are not tangled. A centre support rod is inserted and connected to the frame. Now it's time to open up the sail. The hang glider is almost ready. Just the carbon sail stabiliser rods to be inserted and attached. There are final checks on all the cables, the stability of each sail and height checks to be done, and then the hang glider is ready to be taken out for its test flight before being packed and sent to roam the skies with its new owner. The hang glider is truly a wicked invention. So there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. Velcro, radar and the hang glider, all wicked inventions.